if you have a project that's predominantly 2D based, on average, you have a cost overrun of 15%. That's the baseline. If you use BIM for pre-con and so on, so it's like a hybrid. This is where I guess like more of the advanced projects in the US are. I would say most of the market is here. You have on average 10% cost overrun. If you go full BIM based, your initial cost will actually increase, right? Your design phase will increase because you need to model in everything, right? So your engineering hours go up, but your average cost overrun goes down from 10% to 5%.
On this week's show, the future of BIM with Dave McCool and Tor Hovland, now from Procore. All right, we're back. I'm really excited. I've got a fun new guest to introduce everybody to and an OG to bring back and talk to. So I'm going to start with the OG, Dave McCool. I know folks out there know you, but how you doing, man?
Jeff, doing great. Sorry I missed the last one, but I'm so excited to finally be here and doing this. So
it's all good. I saw your face this morning on a keynote and you know, now you're sitting in my recording studio. So where are you recording from this morning?
I'm in original headquarters. Now it's kind of Austin, but I'm in the original Carpinteria headquarters in California.
The original. That's where we like to get them from. We get a lot of our Procore recordings from there. And you may have heard me say on the intro, now from Procore. We're going to get into this with Tor, but Tor, welcome to the show.
Thank you. Thanks for having us.
Yeah, we love this because where are you coming to us from?
Well, I'm in the beautiful west coast of Norway, a place called Stavanger.
See, we don't get that very often. Dave, he outdid you there. And I got to say, it's 10:30 at night and you're still sitting down and recording with us. So thank you for coming. And I think you guys are going to really enjoy getting to know Tor more. But before we jump into the interview, you guys, remember, we're out there on the social media. Follow us on YouTube. I'm seeing those subscriptions jump up there. So youtube.com/@the ConTech Crew. Follow us. You'll get our shorts. You'll get the interviews and more. All right, crew, it's back. The next evolution of Bluebeam's legendary user conference, XCOM, is here. It's called Unbound, and it's coming to DC this fall, September 30th to October 2nd. You know the vibe. Expert insights from industry leaders, cutting-edge construction tech, Bluebeam training and certification, and unparalleled networking with your global peers. Unbound takes that legacy to the next level with new AI-powered workflows, global AEC connections. But don't worry, they kept the free Bluebeam certifications. Keynotes from my hero, Duncan Wardle, former head of innovation and creativity at Disney, and Apple's legendary co-founder, Steve Wozniak. Use our exclusive code, UNBOUNDTHECREW, for a discount, and join us as Bluebeam evolves and leads the digital construction movement. Register now at unbound.bluebeam.com, and we'll see you there. Use code UNBOUNDTHECREW. All right, so we're going to start this journey with Tor and give a little background. Originally founder and CEO of Novarender, right?
Yeah, that's correct. So my background is actually from oil and gas technology. So as I said, I'm from a place called Stavanger, which is kind of historically been the headquarters of oil and gas. In Norway, we call it oil and gas capital. So this has kind of been where like the heavy civil stuff has been done, like these huge offshore rigs and so on. So I actually come from that side of the industry and started in a company called Vision.io, which did downhole. It's like Google Street View, but for oil and gas wells. So we literally made Google Street View for oil and gas wells. So, and that's kind of the first time I got introduced to this whole cloud thing and building these like cloud native applications. And one of the things I was tasked with when I started there is, I think I was 18 years old, was kind of building this very heavy application and porting it to run cloud natively. And that's kind of which kind of started this whole journey of Novarender.
So talk a little bit about what Novarender is and maybe some of the differences in how the world works. Because this is what I like about, sort of going global with software. It brings in global workflows and global differences in how we do work?
Yeah. So the thing that I kind of learned in Vision.io was that one thing is kind of having really, really good data. Again, we created this like Google Street View thing for oil and gas wells. But the other aspect of that is actually distributing that data out to the user. The stakeholder is actually going to make a decision based on that information and how to kind of make changes to the well, refurbish and so on. And that's kind of what got me into this notion of Novarender, because what we were seeing was that these oil and gas companies, they literally had digital twins of their assets. They'd been using something pretty similar to BIM. It's called PDMS, Plant Design Management Systems. The philosophies are pretty similar. So companies had these like great data sets of their digital assets, but they weren't using it. So the idea of Novarender and kind of where we came from was kind of, let's create the solution that can handle these huge assets. And we literally started with, what's the biggest asset in the world? And that's the universe, right? So our kind of saying was, what would it take to kind of build a technology that could literally render the universe so that we could let our kind of, hopefully, customers at that time, like this was early days, upload any asset of any size and it would just work through the browser on your mobile phone, as simple as a YouTube video, a web page, or what have you, right? This is common now. This is how everybody thinks should work. But back in those days, like desktop was still kind of the go-to. So it's kind of, there are a lot of these like mind-bending kind of ways of thinking about it. Like the way we came up with this render the universe is that if you subdivide the universe, so if you half the size of the universe, I think it's like 124 times or something, you get down to the atom level, right? So when you half and half and half and half and half again, right, you get down to these like really small levels. So we actually built the technology up in that way, where even if you have this huge asset, we would subdivide that asset into something called a spatial tree, so that based on what part of the universe you're exploring, so that's just like a subdivision of that asset or that universe, you only stream in the data that you actually need to see. And that way we're able to kind of jump over all of those kind of problems that other companies were facing, because we took an approach that actually comes from the gaming industry and started implementing that into kind of like heavy civil, like oil and gas asset kind of thing. And that kind of got us into all of this kind of into a world where we kind of built something that could just tackle data like no one's business.
Yeah, Dave, I see you shaking your head over there. I mean, this story and this connection, especially bringing in the gaming universe idea, we've always said that was going to be key to construction actually getting BIM to function and be what it was supposed to be. And you have to be thinking, like, could you ever have imagined early on thinking about any of those models that you showed early on and worked with on a phone, on an iPad, on anything like that?
No, I mean, we've been talking about democratizing BIM for so long, right?
Yeah.
And I just never thought, and I talked about this in the Innovation Summit, but when I announced at Groundbreak, I was like, hey, this is a really big file, that we're opening. And man, the files that people send these days are just huge. It's like megabytes is like, that's small, like, oh, a 500 megabyte file, like that's a small file. Like that's not a big file anymore. It's gigs and they're just getting bigger. And so it was one of those things where if we want to democratize BIM and make sure everyone has access wherever they are on any device, we had to rethink this. And it took we did a lot of, I talked about this too, like a lot of soul searching, Procore, and doing a lot of internal research. And it was just fortunate to have it that we ran into, and fate, had it that we ran into Tor. And it was really amazing and it really feels like that 1 + 1 = 3, and bringing these two technologies together and the teams together. So yeah, really exciting to be here.
Yeah, because you've seen the sort of growth of BIM and been a part of the Procore's BIM focus for a really long time on that journey. And it's interesting because I'm going to bring it back to Tor in a second, but like philosophically, it's even different between how, they approach it and how we here in the States have approached it.
Absolutely. Yeah. Like There's no question. Like the other thing that I also mentioned is like, if you want to go shopping for the best BIM, go to Norway. Because like, if you think about the mandate, you can say, well, in 2016, there was this BIM mandate and there was great marketing around it, but everyone knows who led BIM adoption in the world, right? Norway, right? And so it's really interesting because the way that, and Tor can elaborate on this more, but like it's BIM centric. It's very BIM centric, where like BIM is like a thing that you have to do in the States. Like it's kind of been that way. Like BIM's a thing we've got to do. It's like it's a thing. It's an add-on, right? But if you think about how even Procore has evolved, it's not an add-on anymore. We're part of the platform. And if you even see like a new diagrams of our platform, it's like we are now the connective tissue to all the solutions we have on Procore. And that's how we're building it, is that BIM is central to Procore, empowering and enriching and being enriched by all the tools across Procore now. A very central part of it. But that's philosophically how, Tor, feel free to chime in, but I mean, that's how Norway thinks about BIM.
Yeah, I want to hear, Tor, your kind of take on it as well, because that in the pre-call, it was really eye-opening to me. So talk a little bit about how that difference is, and if you want to be best in class, which, you know, that's exactly what we're saying here, how do you go about it? What's the difference?
Yeah, it's actually like, I think it was kind of a bit of a perfect storm. Like me and another guy whose also name is Tor, right? He came from the game industry. I came from the oil and gas industry, and we kind of built this thing that could render the universe. And we were going at this from a very like low level, like from a very like engineering R&D approach. We spent like 4 years getting like prototypes and demos actually working. And in 2016, I think it was, or it might have been a bit earlier, Norway started mandating BIM for all public projects. And the mandate isn't that, hey, you need to use BIM like in some part of your process. You should build from BIM, like no drawings. You build from the BIM model. And so we kind of spent all this time kind of in R&D and kind of building this great BIM viewer. And then suddenly these like GCs come knocking on our doors and are like, hey, we've heard you guys do cool stuff for oil and gas where you can kind of view these huge models of oil rigs. And they're like, can we use that technology? And we're like, sure, but probably don't need it, right? Your models are small and it doesn't make sense for you guys. And then they start shipping us the data that they were getting. And it was on par on some of the bigger oil assets. And we're like, okay, this is where the game's at. And so we kind of hit market in 2020 that because then the BIM mandates had matured and kind of really exploded. Like the data in BIM has an annual growth rate of 30% per year, so year over year, right? So it's literally exploding. So if you have like the slightest problem now, a couple of years ago, your solutions are gonna stop. Like you need something that can handle data at the level that Novarender can, and we just kind of ended up in this perfect storm. We built this thing for 4 years. We didn't have too much of commercial mindset of where it should be used, and then we just went all in BIM, and the GCs were just all over it. So we went from being like a minor player, and remember, all of the big players are in Norway. Like this became a proving ground for BIM. They were all here, the big names from the US and so on, and we outcompeted one after one after one. Especially in civil, because their projects are huge. They have point clouds, they have GIS data, they have all of these different data types. So we kind of took that market and ran with it. So it was a super exciting time and the perfect time to kind of partner up with a company like Procore that has global reach, right? Because one thing is making the product and the technology, another thing is bringing it out to everyone. So our vision was 3D for all, very simple, right? And I think the best way to do that is together with a global company so you can actually bring that to fruition.
That's awesome, because that is that connection, right? It's BIM centric. And I think you said earlier, it's like, you know, we in the States kind of look at BIM differently and we haven't shifted. So explain a little bit about that difference in view. And then I want, you know, Dave, you can come back in and sort of talk about how taking them global is going to be a fun ride.
Yeah, it comes down to mandates. Like all of the bigger governmental projects, they mandated BIM, right? So they literally said, if you're gonna bid for this project, you need to do a write-up on how you're gonna build from the BIM model, right? Uh, and to do that, you need a tool that can distribute that BIM model in a very simple, efficient way to everyone on the construction site, not just the offices, right? To your like everyday handheld device and kind of, because that's what you have to build from. You're literally like you apply your bid based on the model. You don't get drawings, you don't get quantities. You get the model, and that's what you have. So people kind of they needed Novarender so badly, so that they could literally just open the data and do measurements, do quantities, do all of your basic things. Like people are literally using Novarender every day to lay manholes, pipes, do measurements, create cross sections, kind of all the things you would normally need somebody to sit down and create a 2D drawing for you. They can now do directly in the software in the field, and it's always up to date. The biggest reason for that they mandated BIM is to cut. The reason for cutting down on drawings is you're duplicating data, right? Because essentially, I think almost all big projects now kind of use BIM in the pre-con phase for the engineering phase, but then you kind of try to boil that down into a set of drawings. So every time you update the model, you now have to update those drawings. Or what happens if somebody has that? Like you get into this kind of where you kind of duplicated and fragmented your data set. So the vision of BIM and the mandate that came in the Nordics was that let's try to cut out the drawings totally so that we only have one data set that everybody can rely on, that's always up to date, that's always available for everyone, so that we can do more efficiently engineering and construction at the same time. Because normally for big projects, your model isn't done when you start digging or when you start building. This is an iterative process, and especially for civil work, because you need to pivot your roads slightly due to ground or due to environmental concerns and so on. So your model is built while you're building, and that's where you can't have like outdated drawings laying around all over the place, or literally needing to update drawings every time you update the model. So that's where it came from, and the data is actually showing now that building from BIM has huge gains. Like if you have a project that's predominantly 2D based, on average you have a cost overrun of 15%. That's the baseline. If you use BIM for pre-con and so on, so it's like a hybrid. This is where I guess like more of the advanced projects in the US are. I would say most of the market is here. You have on average a 10% cost overrun. If you go full BIM based, your initial cost will actually increase, right? Your design phase will increase because you need to model in everything, right? So your engineering hours go up, but your average cost overrun goes down from those like 10% to 5%. So you make it back tenfold in the construction phase. And this doesn't even take into account the facility management phase, where most of the cost actually is. Like if you look at a civil project, only 30% of the cost is building the thing, 70% of the cost is operating and all that stuff, right? After it's been built. So we're really seeing the gains now. And it was fun to be part of that. And it's rapidly evolving.
Yeah, and Dave, I mean, those numbers have got to mean a lot, and the shift in the focus. The focus here is, like you said, it's like BIM is support, for the drawings to get made, and then we're drawing and we're updating, and if we're lucky, we're updating. And so talk about how did Procore look at this, and you guys look at this and say like, all right, we can do this. We can take this. And Flypaper, by the way, another acquisition at the same time.
Yeah.
So 2 acquisitions at the same time, and take this and go somewhere. What was that vision like?
Yeah, when we think about the vision for BIM and like call it 2025 and beyond, there's really like think about it in 3 pillars. One of them is that core of just unlocking BIM, call it democratizing BIM, but basically making it, Tor, you said 3D for all, right? That's where we're very aligned. Like we want everybody to be able to access these models, use these models, any project, any size, anywhere, right? And when you think about that, it made a ton of sense with everything Tor's been talking about, because our customers are building the most complex stuff. And I think you talked to Tui about this, of like, I need to get on another call and just talk to you about the projects that you've built. But these projects are crazy. Like they're amazing, mind-blowing projects. And so to support our customers, like we had to rethink, like, what do we do to support these models, to unlock BIM for everyone, to make 3D for all? And so that was like the first pillar, and that's where it made so much sense. But then you look at the other pillars that we have, which is like, okay, now you got this model, everybody's got access to it. Now what do you do? Well, you can use the data behind these to do really intelligent things, coordination being one of those, right? So that's where Flypaper starts to come in. It's like, you think about the processes, and like the number one use case of BIM, even today, if you did a report, it'd be like coordination, right? You bring these files together and you coordinate them. But that process is still, even today, with everything that's going on, won't say the word, we'll see if we can make it through. But with everything going on, it's still a bit manual, right? It's still like you're looking at clashes. Even when we run intelligent clash grouping and prioritization, it's still like somewhat manual. And we feel like there's a world where we can add more intelligence around this, leveraging the data of the models to do not only better coordination and smarter coordination, but also look at like environmental impact, embodied carbon calculations, cost impacts, schedule impacts. And really, as soon as the models are getting ingested in our system on our connected platform, we're providing intelligence to let people make better decisions and iterate faster during the design phase, right? So when you think about it, it's unlock BIM, power, you use this model as a platform component to power our different systems and enrich and be enriched by those to make better decisions during the design to reduce that rework cost and those cost overruns when you get to construction. And then the last pillar that we think about a lot is connecting. How do we connect the data across our platform with these models? I use and I may have said it at Groundbreak too, of like the story of a door. But like at the end of the day, you should be able to click any object in that model and know every single thing that happened to it from design through construction. Tiffany, who's on our team here, it really works with owners a lot, is expert in digital twins and trying to help people understand that definition because it's a very blurry term. Refers to as kind of like a execution twin. It's like all the stuff that happens during the execution phase of the project and like capturing that in real time and leveraging it. So you can say like, how much was installed today? And the model's lighting up with that information. You're getting real-time feedback from the model, from the field. And so in a sense, it is a digital twin, but it's for the execution phase. And then at the end of the day, the owner has this great asset of all this information that's been aggregated in that model. And so when we think about, where we're heading with this, it's really at its core foundation, make it available for everybody, unlock BIM, and then add intelligence on top of it with our platform and connect it to all the different tools across the workflow. So at the end of the day, you have this robust data set of aggregated information that you can use for the life cycle of the project.
That sort of everybody can use along the way and consume. And I love the, like basically hydrating the model with what's happened. I like that execution twin. I've always called it a data twin because so much of what happens is, captured in a daily log. It's captured in other formats that, can be accessed through the model itself. But there was always the problem of bloating the model, of making it too big. And that's, I think, a mind shift now that, Tor, you're saying we can sort of forget about that given the way you guys took the time to approach building it.
Exactly. Like we're seeing projects now where we have a really big, I think it's the world's longest undersea tunnel being built in Novarender. So they're going from both sides. So hopefully they're going to meet in the middle somewhere, like a couple 100 meters under the sea.
The mind-blowing projects, by the way, that.
Yeah, it's insane. But and they're uploading point cloud, so they're laser scanning. I think it's 6 times per day or something, and they're uploading that to Novarender so that you can get real-time deviation reports between we call it a theoretical model, right? Because what actually gets built on site is never exactly like designed, right? It's impossible. So what we're doing is that we get this tunnel, a theoretical tunnel that's like an IFC, a model, right? And then we're comparing that against the laser scans that we're receiving constantly. And then we color code the point cloud, like red, you're under, green, you're good, right? And then maybe purple, you actually went too far. So that they can constantly optimize the way they do their tunneling based on real-time data. And people literally in the tunnels get this data more or less real time because they put in like internet and everything in that tunnel so that they can get that deviation report as a constant feedback loop, so they can alter that, because this comes down to economics, and also as you're into environmental concerns, is that what has historically been done in tunneling is that you always overbuild slightly, because being too small, it's like a bankrupt problem, because sometimes you can't backtrack your equipment efficiently. Like, it's super difficult to do. So they will always kind of overbuild slightly. But with Novarender, you can get much closer to the theoretical limit of kind of just building exactly what you need. And then you're also reducing the amount of concrete, you're reducing the amount of material you're pulling out, the material you need to stuff in. So it's like it has like huge monetary benefits for the clients and GCs that are actually able to utilize this efficiently, and they're changing their processes, the way they work now. So they on a daily basis, when they come in to work, they literally have a 70 or 80-inch screen with no render and kind of the deviation report. So every manager, the first thing he comes in and sees is this report, and it's live. So they can go in and adjust and kind of alter and change constantly.
Yeah. And so this is great because you're talking about these incredibly large jobs and complicated that, you're working on the civil and the infrastructure side of things. And I mean, I can just imagine saving earthwork and saving that, because these machines that are digging the tunnels are massive, and a little issue can become a big problem real fast if you're not getting that. And historically if you look back over, some of the largest disaster projects were attempts to build tunnels, attempts to do boring in places that it didn't go well. And so it's a huge opportunity, but this is cool because it's almost as critical and needed in vertical construction and in our, what we would consider the areas that we've done it better, not better, but we've done it more consistently here, but haven't seen the gains. The gains are those reports of standard deviations being able to be had quickly. And, if you're doing 30 floors, if you can see the standard deviation on the first floor, you can adjust. Because you're right, we never build what we model or drew in CAD because the world's different, right? It just
Exactly.
it's not everybody looks at it like, oh, what, you can't do it? No, it's not a goal you should try to attain. Right? It's just unattainable because things are going to happen. The world is ground is different.
Exactly.
What happens in the field is different in ways, but creating a continuous feedback loop allows us to adjust to that and measure it and understand where we are. And so, Dave, I've got to believe you can see the value in taking these learnings from these massive projects in the civil world and moving them into the vertical construction world.
Yeah, absolutely. I mean, you think about when I saw, and I talked to some of these customers too, the one that's doing this tunnel. And, my mind immediately went to not only just installation tracking, but also, floor flatness, beam deflections, all the stuff we do in vertical construction that we do analysis on, similar to tunnels. Now you're doing that same process so that you can make sure that, you get it right the first time and you're not going back and doing rework. If you watch the Innovation Summit when Chris and Julian were talking about it, but I don't know if they mentioned this, but 30% of time spent in construction is doing rework and like redoing things. And I was like, that is a crazy stat, to think that that's what we're dealing with right now. So a lot of room for improvement and being, more proactive and understanding it so you can get ahead of that rework and reduce those costs.
One of the stats I heard from Jules, the GM of Europe in Procore, the number eludes me, but there's also this stat on like safety incidences versus rework, like how much
60%,
right, is due to kind of these unforeseen things that happen, and then you need to do some rework, you need to fix something, and then things move quickly, and then people get hurt, right? So that's why we really believe in kind of when you gather this information at the rate you can with Novarender, because there's no limit to kind of how much data you can put in there. We can actually get people home safely, like from these tunnels, where you can actually see that you have enough concrete so it won't fall out, or you won't kind of have these unforeseen events kind of happen.
And Jeff, this goes back to like the vision, right? I mean, you have all this tribal knowledge and all these people on your team that have been there and seen some of those challenges. But you think about where BIM has been, and it's like, siloed. It's kind of siloed, and we've been trying to break through this. That's those silos, and I think we've done a pretty good job. But now, again, like the models are getting so big, now we're at a new, new tipping point of like, now we got to break through this challenge so that we can continue to unlock BIM, so that everybody has access to it, so that we don't end up in these rework situations because of the rippling effect, not just from a cost perspective, but exactly toward what you brought up of like 60% of injuries on a job site are caused by rework. And it totally makes sense because you get in a rush and you take shortcuts. And when you take shortcuts, you get hurt.
And you're working in a situation that's not sequenced correctly. And so many times you're working in dangerous areas in concrete above your head and trying to, put in a new hanger or, adjust something or get through a wall or do something. And it creates, I can see it creating the situation for injury. And if you think about it, man, since I started in this, James Benham, his old talk was like, where can you make money in technology in construction? And it's like, you guys don't realize you're burying bags of money in rework on every job site. And if we could just harvest that, and everything was aimed at harvesting it. But you're right, we've consistently run into barriers to keep us from getting all the way there. And, think about that 30%, that's margin, right? There's room for money. We're like afraid in construction to say like, we're here to make money. I think the key thing would be we take that 30% and we redistribute it across everybody, and everybody makes a little bit more, and still the job costs a little bit less than it was estimated or intended to. I don't want to say jobs are going to get cheaper, because that goes to the 2E discussion that we had about like, and Chris and Julian brought it up today, is like, everybody's seen all the curves and crap they throw at us for how bad we are in construction, yet they don't look at like the world's longest tunnel and high rises and Millionaires Row in New York, and like all of these crazy stadiums that are the highest tech they've ever been. Those are always going to get more expensive because owners want to build the best and the greatest and the next, but they don't have to become astronomically more expensive because we don't know what we're doing and we're rebuilding them 30%. That means you're literally 30% of the building is being rebuilt before anybody gets into it. That's insane. So, definition of insanity, construction without BIM. There you go. Now I'm interested though. You guys have come together, and toward this opens up an opportunity for, somebody who thought about the universe and brought it back down to doable. What are some of the things you see that now you have an opportunity to kind of sit back and go, okay, what can I do next? And what can we do? Because you now got access to Dave and the team, and, sort of this world opened up.
I actually think it goes back to the 1, 2, 3s. Like, getting your basics right is so important. Like, getting BIM out to everybody in the field efficiently and connecting that up to kind of the platform, your RFIs, your maybe even your schedule and your bid, and kind of all those things, and getting all of that connected so you can actually see relations between that information. I think that's actually where you're going to see like these immense gains and untapped potential, what you're quoting, the 30% thing. It's kind of, I think that's where you're actually going to see people being able to work in a way that they thought was unimaginable just like a couple of years ago, by getting their 1, 2, 3s in BIM at the level they are in other parts of the process. Maybe you have some points, Dave, there.
No, I think it's spot on. I mean, I think that, having, making sure these models are accessible and then connecting them is like huge, because that's where, I think about the world where once we're connecting to all these different tools and where we're heading, you say like, what submittals are going to keep me from hitting my schedule this week? And it just lights the model up. It tells you every single thing that's going to cause a problem this week or this month, because you have all of the information across Procore connected, and it's enriching this model. So for both like visualization, but also aggregation of all that data on these objects.
Well, yeah, that aggregation of understanding the schedule and understanding the model and understanding also the material flow,
Exactly.
and the availability of the work and the crews and the sequencing of it. And it can get ahead and really go from defense to offense and getting out ahead, because that's the beauty of, and I've joked, like a lot of people say like, oh, well, construction are great problem solvers. And I've said at one point well, like, but really, should they be? Like, shouldn't they just be great at construction? And then I was challenged back, like, no, they are problem solvers. And I had to take a step back and say, actually, they are. The problem is we're solving problems that are like right here. We should be looking way out and solving problems before they're really a problem, because then it's just a decision. If it's a material, right? If it's a material that you can't get, well, can you sub that material out? So like you said, my submittals, what's going to get in the way? Well, right now I can't get this, but is there a suitable alternative that I can get in front of an engineer or get in front of the team, make sure it fits the submittal, make sure it fits the requirements, and I can acquire it and get ahead. So you can still be a problem solver, but your problems should be much further out in the future and much more impactful.
And it's also kind of, this is where we use a word called federated models, and that's where you bring in all of the disciplines, right? Because if you look at a lot of the work that has been done historically, both in 2D and 3D, is that people are very concerned about their trade or their discipline and looking at that isolated. So when you're trying to make a decision where you're trying to shift something or do something or adjust something, you're looking at your trade without kind of considering what's around you. And I think this is where BIM kind of becomes kind of the unifying solution, where we had a saying over under, like, creating obvious solutions to complex problems. Because when you have a BIM model and maybe you do like a cross section, so you can see that pipe going through, and the question is, should we move it to the right or should we move it to the left? And then you can see in the model, well, there's literally something else coming here on the right side, but it's not here yet. But I can see that in the model now. So obviously we should go to the left, right? This becomes like, non-decision, but it's not trivial if you don't have that data in front of you, right?
Well, yeah, Dave, you've never seen that problem happen before, right?
It's like what the tour is hinting at too. Like, it's a paradigm shift, right? In a way, because one of the things that I used to do at McCarthy all the time when I was getting the team to, training engineers on how to do coordination, was I would tell them, like, take all the level 1 sheets and get them together, and then take all the level 2 and get them together, because our drawings are inherently siloed. They're like architectural and then structural and then mechanical. And so to see how they relate to each other, you're sitting here doing cartoon flips, like, oh, is there something beside that thing that I can't move to? And you don't have that problem with a model, right? It's all there. And so you can start to see those relationships, and it's no longer like there's an architectural set, there's a structural set. The information's there to make the right decision.
Well, yeah, and there's a federated set, to your point, Tor, but then there's also the live as-built set that's coming back in real time to fulfill the circle and create this loop so that you have it. And then in real time, what you wanted, planned, designed, and are now executing, and how you can adjust. And I can see this opening us up more and more in construction to the idea of design for manufacturing and assembly, and doing things in a more componentized way, and not thinking about just our trade, thinking multi-trade, thinking across the construction life cycle, because you have the access to it. The other thing was, we didn't have the ability in the past to really, in the field, look and know without having to go through a headache. And you have a crew. Do I go to the left or do I go to the right? You didn't know.
Yeah, exactly.
And so it's just knowledge at the right time. I keep saying this. It's right information, right person, right time, right platform. There it is. That's what everybody needs throughout the life cycle of the process. And then we can hopefully someday maybe feed this information back that we've learned, and we can learn from it. Imagine that we can learn from the past to inform the future. Wow. There it is, you guys. We're gonna call it. I'm gonna say, but I'm just also gonna preface this with there are more conversations to come. We wanted to give a shout out to what happened and the acquisition and the opportunity, and tell a little bit of backstory and try to weave this together, because to me it's a huge moment in BIM for the field, BIM for the average person, so to speak. And so it was worth having you guys on and talk, but I think we're going to have some more conversations in the future.
I love that. Jeff, thanks so much for doing this and hosting it, and the labor of love that you do for the ConTech Crew. And it's such a great show. So I really appreciate you having us.
Thanks, Dave. And you're one of my boys in the business. It's always great to see you. And so I'm excited that we get to sit down again in the future. And Tor, it has been awesome to meet you, man. And I want to dig into that brain a little bit more, because anybody who actually has the gall to say, I want to render the universe, and then gives me an equation for how you do it, that's unique, man.
Thanks for having us.
Thank you for tuning in today to geek out for our interview with Dave McCool and Tor Hovland. To read all our news stories, learn more about our guests, and to listen to the show, visit thecontechcrew.com. This is the ConTech Crew signing out. Until next time, enjoy the ride and geek out.